Dear students, in the last video, we discussed about the concept of region-based segmentation. So there we discussed about region growing algorithm. The region growing algorithm is one of the simplest algorithm. Here we choose a seed pixel. We choose one of the arbitrary pixel as a seed pixel. Then we go on adding the neighboring pixels only if they satisfy some predefined criteria. So we are going to stop the region growth only if the required criteria is not met. We repeat this entire process until all the possible regions are found. So that based on this algorithm, in this video, we are going to discuss one of the numerical example. Here you may expect such problems in the exam. Here the problem is like this. Suppose that we have the image given below. They have given an image which is just a matrix elements. These matrix elements, they represent intensities of the pixels of the image. Here what it says is use the region growing idea to segment the object. The seed for the object is center of the image. You have to use this center of the image as the seed pixel, and what it says is the region is grown in horizontal and vertical directions, and when the difference between the two pixel values is less than or equal to 5. Here the question is like this. These are intensity of the pixels of an image. You have to choose the center pixel as the seed pixel, and you have to consider the neighboring pixels as belonging to the same region only if the difference between seed pixel and the neighboring pixels is less than or equal to 5. That is the task we have to accomplish. Okay, here again we can make use of either 4 connectivity or 8 connectivity. 4 connectivity means we can use only the horizontal and vertical neighbors. Okay, here we have the result of 4 connectivity. So if you look at this solution, it is like this. Here we have the center pixel 60. Okay, we just check only the horizontal and vertical pixels. So if you compare 60 and 10, the difference between 10 and 60 is not less than or equal to 5. That's why this 10, the pixel 10 will not be added into the region. Then we compare this 60 with 64 and 65. When you compare with 64 and 65, the difference is less than or equal to 5, so that we add these two pixels 65 as well as 64. Then similarly, then similarly, we continue with the other pixels. Like if you consider 65, if you consider 65, for 65, we can we cannot add 59, we cannot add 10. However, for 65, 67 can be added because the difference between 65 and 67 is less than or equal to 5. Then again, you can consider this pixel 70. When you consider this 70 as the seed pixel, that time you cannot add 10, right? So we cannot add any other pixels for 70. Then similarly, you have to carry out this process for all other pixels. So from this 64, if you take as a seed pixel, you can add 60, then you can add 69 and so on. With 69, you can consider 70, right? 70 can be added with 69. Like that, you have to continue the process. For 59, we get 56. For 56, we get 60 because the difference is less than or equal to 5. From this point 60, we can add 62. For 62, we can add 65. into the same region. The idea is very simple. First, select the seed pixel. Here it is 60. From that seed pixel, you just check horizontal and vertical pixels. If their intensity is less than, or if the difference between seed pixel intensity and those horizontal and vertical pixel intensity is less than or equal to 5, those pixels can be added. After that, you have to select next pixel which is already in the region as seed pixel, and again compare its horizontal and vertical pixels and can be added if the difference is less than or equal to 5. Otherwise, those pixels can be omitted. Okay, so this is the result which we obtained by using 4 connectivity. Similarly, we can also have with 8 connectivity. With 8 connectivity, what we do is we check all the surrounding pixels. However, with 4 connectivity, we compare only the horizontal and vertical pixels of that seed pixel. But here it is not like that. Here we compare all the surrounding pixels, which include horizontal, vertical, and also the diagonal pixels. So this result we obtain by using 8 connectivity. Students, please try to solve such examples. You may expect such example in the exam. Okay, next we have one more algorithm based on the region-based segmentation, that is region splitting and merging. So in this case, as the name itself indicates, we go on splitting the image based on some criteria. If the splitted parts, if they have identical properties, if they have similarity based on some criteria, then we are going to merge them. The concept can be explained in terms of steps. First, we take the whole image as area of interest. Area of interest means it is the entire image we consider at the beginning. Then we check whether all the pixels in this region they satisfy some predefined criteria for similarity. We are going to check all the pixels of area of interest whether they satisfy some predefined criteria or not. If they satisfy the criteria, if the condition is true, the area of interest corresponds to region of interest. Here, area of interest is different, region of interest is different. A region of interest means it is the part of the image which is to be segmented. Okay. Otherwise, if the condition is not met, we are going to split the area of interest into sub areas. Then we repeat the above process continuously until no further splitting is possible. The concept is like this. First, we take whole image as area of interest. Then we check whether all the pixels in the region they satisfy some predefined criteria or not. So if they satisfy the condition, we assume that those pixels they belong to region of interest. Otherwise, we are going to split the area of interest into sub areas. We repeat the entire process continuously until no further splitting is possible. Okay, here we have shown the same thing with an example. Okay, just assume that I it denotes the whole image. You have an image which is represented as capital I. So here, first what we do is, if all the pixels in the image I, if they are not similar, we are going to split that image I into 4 sub-regions. It's just an example. You can have any approach for splitting and merging. Here, the example is like this. If all the pixels in the eye, if they are not similar, we divide the image I into four subregions. We call these subregions as I1, I2, I3, and I4. Assume that the pixels in the region I1, I2, I3 are similar. After splitting, assume that the pixels in the region I1, I2, and I3 they are similar, but those in I4 they are not similar. Now what we can do is, okay, I1, I2, I3 they are going to form three segments. But however, if I4 is not having similarity, that region I4 can be splitted once again. So you can split this I4 segment into again four divisions called I41, I42, I43, and I44. Suppose if after segmentation, if I43 and I44, if they are similar, they can be merged as shown here. If I43 and I44, if these regions, if they are similar, they can be merged. And we will be left with I41, I42, and I43. Okay, assume that this is the entire image we have I, and in this image I, finally we can get the segments I1, I2, I3, I41, I42, I43. They may be representing the different objects or different constituents of the entire image I. This concept we call it as region splitting and merging. Students, again, these are very important concepts. You need to explain with example. You better to write the steps for the concept, and also you can give the example in the exam depending on marks. Okay, thank you students. This completes the topic image segmentation. Thank you very much.